So in this video, what we're going to do is use GeoGebra Classic 5 to determine the input values that are needed to generate a specified or given output. So in a previous video, we generated a quadratic model using Microsoft Excel that outputs the number of blades of grass we expect to grow in an experiment, given a specified input of nitrogen measured in milligrams per liter. So here's the model that we found in that video, and the question says, what is the projected quantity of nitrogen? How much nitrogen? And remember, nitrogen is the input for our model, nitrogen, in milligrams per liter, and the output is grass blades. So what is the projected quantity of nitrogen? How much input do you need to yield 17 grass blades? And what we want to notice is that 17 is going to show up on the output axis somewhere over here. 17 is a number on the output or grass blades axis. And if we draw a horizontal line, we try to draw a horizontal line, the line y equals 17 grass blades, we see that it intersects the quadratic model into spots. And what our job is to determine the input quantity of nitrogen that generates those grass blade outputs. So what we're going to do is use GeoGebra to do this. We're going to draw the horizontal line y equals 17 and then find these two intersections. So going over to GeoGebra, in which I've already typed the model, I then want to graph the line y equals 17 to get that horizontal line that we drew in PowerPoint. So y equals 17, and that represents 17 grass blades, and then we see we have intersections into spots. So up here in the upper left where we have the point tool, we open that drop down menu and grab the intersect tool, and we just hover right over the intersection and click it, right over the other intersection and click it, and that gives us the two ordered pairs. And by giving us the ordered pairs, it gives us the nitrogen values that we need to generate an output of 17 blades of grass. So we see that either 99 or about 510 milligrams per liter of nitrogen generates the needed output of 17 grass blades. The alternative, if I turn these off, the alternative with the intersection tool, so I still would use the intersection tool, is I can actually click on the graph itself any place, and then click on the other graph that for which I want to find the intersections. And sometimes that'll mark both intersections at once for you, which it did in this case. So there's another way to find the inputs you need for a specified output. Again, GeoGebra will give you those ordered pairs, and your job then is to interpret the input values in those ordered pairs.